Good morning. This is lecture of physics. In this I'm going to revise you unit second. Unit second deals with magnetostatic, means magnetic field produced due to constant current. In our previous lecture, we have done the important question, that is the magnetized bound current densities, that is Kb and Jb, and magnetic field intensity, that is H. So I'm going to start you from magnetic field intensity. First of all, bound surface current density, that is Kb, which is equal to m vector cross n unit vector. Here B stands for bound currents and Jb is equal to del cross m vector. From the fundamental postulates of magnetostatic, which is equal to del cross B is equal to mu naught J vector, and del cross B vector upon mu naught is equal to J vector. Now total current density J is equal to Jb plus Jf. This is J, that is J, and this is also J. Now equate these two equations. So after equating, we get del cross B vector upon mu naught is equal to Jf plus Jb. Now here this is Jb. We have to fill the value of Jb here, and the value of Jb is del cross m. So del cross B vector upon mu naught is equal to Jf plus del cross m. So after taking this factor towards the left hand side, we get del cross B vector upon mu naught minus del cross m vector is equal to J vector. Now bring del cross as a common from these two factors. We get B vector upon mu naught minus m vector is equal to Jf. Now this value B vector upon mu naught minus m, which is equal to H vector, means del cross H is equal to Jf. So H vector is equal to magnetic flux intensity, and del cross H is equal to Jf, and H is equal to B vector upon mu naught minus m. This is magnetic field intensity. Now in the next, we have, after we taking H vector, now we have to apply the Stokes theorem on equation number 1. So after applying the Stokes theorem, we get del cross H dot ds surface integral is equal to Jf vector dot ds vector surface integral. Now this is a Stokes theorem. We have to apply Stokes theorem here. So after applying, we get Stokes theorem converts surface integral into line integral. So we will get H vector dot dl vector is equal to surface integral of Jf dot ds, and this is equal to If, means current due to free charge carriers. So line integral, closed line integral H vector dot dl vector is equal to If. Hence this relation states that the circulation of magnetic field intensity vector H around any closed path is equal to the free current flowing through the surface bounded by that path. So this is simply the Ampere circuital law for the magnetic field intensity. Now the next topic is magnetic susceptibility and permeability. Susceptibility is simply a term which shows how much our material get magnified when we applied magnetic field or when we placed our material inside the magnetic field. So for the expression of the magnetic susceptibility and the permeability, we have some expression. The magnetization vector, that is capital M, is directly proportional to the magnetic field intensity, means magnetic field intensity as the magnetic field intensity increases, in the same amount of magnetization the material get magnetized. That's why M is directly proportional to H, and H is applied field. So after removing the proportionality, we have get here a constant, and this constant is psi m. So M vector is equal to psi m into H vector, where psi m is magnetic susceptibility. And psi m having the different values. If psi m is positive, means paramagnetic substances. If psi m is negative, means we are dealing with diamagnetic substances. If paramagnetic substances are those when we are applying magnetic field to the material and all the dipole moment get magnetized in the same direction as in the direction of the magnetic field, then it is called paramagnetic substances. Diamagnetic substances are those when magnetic field and the dipole moment moves in the opposite direction. So from the above expression, from the expression of the H is equal to B vector upon mu naught minus M. Here this is M, that is magnetizing vector. So after that we get this is H and this is M. So we have to fill the value of H here. So we get B vector is equal to mu naught H vector cross M vector. Now substitute the value of M here, and the value of M is psi m into H vector. So after filling the value, we get B vector is equal to mu naught into 1 plus psi m into H vector. This is equation number 1. And mu naught is a permeability of the free space. Mu is a permeability of medium. So B is equal to mu into H. This is magnetic field intensity H and this is induced magnetic field. So equation 1 and 2, after equating 1 and 2, we get mu r is equal to mu upon mu naught, which is equal to 1 plus psi m. Mu r is a relative permeability, which is equal to permeability in the medium to the permeability in the vacuum, which is equal to 1 plus psi m. So mu r is equal to relative permeability. Mu r is a dimensionless and psi m is the also dimensionless. When the two quantities added and subtracted, they should be of the same unit. So psi m is a susceptibility, magnetic susceptibility, and mu r is permeability. So this is the expression for permeability and susceptibility. Now the next question is from unit 3rd, and the name of the unit is time varying field. First of all, in this unit we have to discuss the Faraday's law, and before Faraday's law we have to know about the electromagnetic induction. What is electromagnetic induction? As we all know, what is magnetic flux? Magnetic flux deals with the magnetic field lines per unit area. And electromagnetic induction deals with the magnetic flux. Whenever the magnetic flux changes, then induced EMF and induced current is produced. And that induced EMF or induced current is known as the phenomena through which the induced EMF and current is produced is known as electromagnetic induction. So first of all, what is electromagnetic induction? So it is the relative motion between the loop and magnet, which causes the deflection of the current produced in circuit. This induced current is due to the presence of an EMF. EMF means electromotive force in the circuit. This EMF is called induced EMF, and the phenomenon of induced EMF in the circuit is called electromagnetic induction. So, as I told you, whenever the magnetic flux linked with the circuit is changed, then induced EMF and induced current is produced. And the phenomena of the production of that induced EMF and induced current is known as electromagnetic induction. So what is the definition of electromagnetic induction? It is the relative motion between the loop and the magnet, which causes the deflection of current produced in circuit. This induced current is due to the presence of an EMF, means electromotive force in the circuit. This EMF is called induced EMF. The phenomena of induced EMF in the circuit is known as electromagnetic induction. Now we have to discuss the Faraday's law, and Faraday's law depends upon electromagnetic induction. Faraday having two laws, and we have to do both the laws one by one. Now, what is the Faraday's law? Number 1. First of all, as I told you, Faraday's law depends upon electromagnetic induction. And how it depends? So, the relative motion between the loop and the magnet causes a magnetic flux through the area bounded by the loop to change. And this change in the magnetic flux produces a current in the circuit, and this is also known as electromagnetic induction. Now, the Faraday's law depends upon this phenomena, that is electromagnetic induction, and how it is depend. So, in the first law, what is the first law? As I told you, when the magnetic flux change of the circuit, an induced EMF is produced. So what is the first law? Whenever the magnetic flux linked with the circuit changes, an EMF induced in the circuit. So what is the first law? Whenever the magnetic flux linked with the circuit changes, an EMF induced in circuit. The magnitude of that induced EMF is directly proportional to the time rate of change of magnetic flux. So in this mathematical expression, you can see E represents the induced EMF proportional to rate change of magnetic flux. Rate change word is that when any quantity changes with time. So d by dt represents the rate change of phi represents here magnetic flux. So what is the first law of Faraday? Whenever the magnetic flux linked with the closed circuit changes, an EMF induced in circuit. The magnitude of induced EMF directly proportional to the time rate of change of magnetic flux. And this is the first law, that is E is directly proportional to d phi upon dt. This is very important law. Here E is induced EMF, phi is magnetic flux, d by dt represents the rate change of magnetic flux here. Now, what is the second law? Second law is also important. Now, that induced EMF, the direction of that induced EMF always oppose the cause that produced it. For example, what is the cause of the induced EMF? That is change in magnetic flux. So it opposes that thing, means it opposes the change in magnetic flux. So what is the second law? The direction of induced EMF is such as to oppose the cause that is responsible for changing the magnetic flux. Means what is the first law? E is directly proportional to d phi upon dt, rate change of magnetic flux. Now according to second law, E is equal to, after removing the proportionality sign, we get minus d phi upon dt. So what is the second law? The direction of induced EMF is such as to oppose the cause that is responsible for changing the flux. Means we have to apply negative sign in front of rate change of magnetic flux. Because of change in the magnetic flux, we get the induced EMF or induced current. So according to second law, it opposes the cause that produced it. And this second law is also known as Lenz's law. And Lenz's law deals with the conservation of energy. Means mechanical energy is converting into the electrical energy, and electrical energy is converting into the mechanical energy. So these are the two laws of Faraday's. First law is, whenever the magnetic flux linked with closed circuit changes, an EMF induced in circuit. The magnitude of induced EMF directly proportional to time rate of change of magnetic flux. Means E is directly proportional to d phi upon dt. And the second law is, the direction of induced EMF is such as to oppose the cause that is responsible for changing the magnetic flux. Means E is equal to minus d phi upon dt. And the Faraday's law depends upon electromagnetic induction phenomenon. So what is the electromagnetic induction? The relative motion between the loop and the magnet causes a magnetic flux through the area bounded by the loop to change. This change in the magnetic flux produces current in the circuit. So this is what is the electromagnetic induction? Whenever the magnetic flux link with the circuit is changes, then the induced EMF is produced in the circuit, and that the production of that induced EMF and the current is known as electromagnetic induction. Here are the various experiments for the production of the electromagnetic induction in the circuit, which we have done in our next lecture. I hope you will understand these topics of today's of unit 3rd, that is time varying field. Thank you.